All right, we are on water. This is one of the three micronutrients. So the other two are vitamins and minerals. So now we've covered the six classes of nutrients after this week: um, carbs, lipids, proteins, water, vitamins, minerals. So water is about 60, more than 60% of our weight. And in children, it can go up to even around 75% of the weight. And I would say that in children, more of their water is outside of the cells than in the cells. So they're actually more prone to dehydration as you're younger. So, water does a lot of the things that you might think it does. It acts as lubricating, but it also maintains blood pressure. So when you drink water, water goes into your body, into your stomach, then it's going to go into your blood. So the more water you drink, the more blood you have. The more blood you have, the higher the pressure goes. Of course, there's like a limit to that. Your kidneys are constantly taking the blood and cleaning it, and they're taking water out of the blood and adding it to the urine. So the converse is also true that if you don't have enough water, your blood pressure is going to go down. So not enough water equals not enough blood. Not enough blood equals lower blood pressure. So water contributes to blood pressure. Water also contributes to body temperature. Of course, we sweat. You don't realize how much sweating we do, even when you don't notice it, but you are sweating even now. So water exists in different states in our body. So when we look at fluids in our body, we usually look at things as being intracellular or extracellular. Intracellular inside the cells, extracellular outside of the cells. So interstitial fluid is the fluid in between the cells. So I kind of like to envision cells as being like houses in like a residential neighborhood. And then the space, like the driveway and the grass, all that area is the interstitial fluid. Right. And then in this analogy, the street would be like a blood capillary. So water intake is related to blood volume, which is related to blood pressure. So how much water do we need a day? It kind of depends on how much water we're losing in a day. So this is the rough breakdown. And so just if we didn't go over it yet, there's 1,000 milliliters in 1 liter. So if I were to say 1 liter, it's the same thing as saying 1,000 milliliters. So about 500 milliliters to 1,400 milliliters is urine. 150 milliliters is feces. This can is about close to 500, I don't know, 355 milliliters. So this is about 350. This is about how much liquid you lose from your lungs every day, right? You lose about 2 to 3 times this in sweat, and you lose like 3 water bottles in urine. So not all of those can we control. You can't control how much water you lose from breathing. Can't control how much you lose from feces. But you can control sweat. That's not a good idea though, because when you control how much you sweat, you're going to overheat. So the main one that you can control is urine. You can produce a lot of urine, or you can produce not so much urine. You have to produce at least 500 milliliters or half a liter, no matter what, even if you don't drink. So you have to excrete, you have to get rid of the waste in your blood. So, what is the adequate intake of water? Because we don't have an RDA for water. You can't come up with an exact amount for water. Depends on how much you lose. Is it a hot day? No. So, about 2 to 3 liters is how much water you should have. And that works out to about 7 to 11 cups, or they say 8 to 10 cups. So, there are some hormones that we have that try to keep our blood pressure up. Our body's built to keep blood pressure up, not to lower it. It's built to raise it. And so, um, essentially, what these hormones do, and if you're a nursing student, you're going to come across these again. Um, Antidiuretic hormone, also called vasopressin, tells your kidneys to keep water. So if you're dehydrated, you're going to tell your kidneys, don't just make urine, like an unlimited amount of urine, right? Just hold on to all the water you can and just use the minimum amount in urine. That's when your urine color is going to be like a dark yellow color. The other way to keep blood pressure up is to constrict the blood vessels. And so that doesn't have anything to do with water necessarily, but that's what angiotensin does, angiotensin 2. And then if you look at the fourth one on here, aldosterone, it's also going to tell your kidneys to hold on to water. Don't use it in the urine, but it does it in a different way. Holds on to sodium. That's the Na+. So sodium influences where water is. Wherever sodium is, that's where water will stay. So if you can influence your kidneys to hold on to sodium, you're going to hold on to water. If you hold on to water, you keep blood volume. If you keep blood volume, you keep blood pressure. So the major minerals lecture, which is coming, is electrolytes. So electrolytes are also major minerals like sodium, potassium, chlorine. There's a few other ones. The only thing well, actually, before I get into that, so electrolytes, something about minerals is that they're either positively charged or negatively charged, and that's kind of what I'm writing here. So it's a good idea to know that cation and anion, those terms, right? So anion, cation, and so that's one thing we look at when we look at electrolytes. And the other thing we look at is where they are in the body. Are they inside of cells, intracellular, or are they outside of cells, extracellular? Right. And so a lot of these, if you have something like positive and negative coming together, that makes a salt. The salt that we know is table salt. That's sodium and chlorine coming together. The positive and the negative attract to each other. Right, but there's other ones too. So just kind of a last thing here. I don't believe this is in your chapter, but I thought you'd just like to know the difference between hard water and soft water. It's the minerals that are in water, right? So all water has minerals in it unless you get deionized water. So for soft water, sodium is the main mineral in it. And for hard water, calcium and magnesium are the main minerals. As far as like drinking, as far as taste, because these all influence taste, hard water tastes a little bit better than soft water. Not a little bit, a lot better. But that's what water companies do. They just manipulate the amounts of calcium and magnesium and sodium, and they make it taste differently so it could taste like it came from a glacier or something like that. Right? If you ever really want to find out about different bottled water companies and the bottled water industry in general, the National Resources Defense Council, they put out a really good report on bottled water, and you'd be really surprised. nrdc.org, and then just search for bottled water. And you'd be really interested to see that it's not much different from tap water. Okay, so that's all we have for water, but do look at the other PowerPoint and do read the chapter, and let me know if you have any questions.